Welcome to our today's Pioneers Talk, how crafted scrap improves the steel quality and reduces CO2 emissions. My name is Christoph Stangl. I'm Marketing Manager at Primetals Technologies and I will be your today's moderator. Well, with me are today two experts. On the one hand, it's Andreas Melcher. He is Product Lifecycle Manager for scrapyard automation at Primetals Technologies. Welcome, Andreas.
So it's my pleasure to be here with you and our audience today. Hello.
Okay, perfect. And the second expert is Heiner Guschall. He is CEO from SICON, Germany. Heiner, glad to have you here.
Thanks for the chance to be here. It's a great pleasure.
Perfect. And I think we have a great audience as well today. I've seen that the interest in the forefront of this talk was massive. I hope a lot of people are also live now at this moment. So within the next about 45 minutes, Andreas, Heiner and myself will discuss how crafted scrap enables the production of high quality steel as well as reduces CO2 emissions in a steel factory, how you can convert conventional scrap into crafted scrap, and also how essential the automation of production processes and the logistics in the steel factories. So at any time if you have questions you would like to ask one of our two experts, please just add a comment to this live stream as if you're used to it. If you would just put a comment on a social media post. Later on during this live streamed interview, I will just read out some of your questions and ask it to our two experts. So this is a Pioneers Talk interview, so let's start pioneering. Now, SICON is a specialist in the processing, analysis and sorting of scrap on the one hand, and Primetals Technologies is, among a lot of other things, of course, a specialist in the identification and automation of production processes and logistics, or identification of optical identification of scrap. So most likely both of the companies have already assisted a lot of steel producers to pimp up their scrap yards. But before we go into discuss about the specific solutions and how this works in detail step by step, I would like to go one step back and just discuss with you what is nowadays the conventional way how steel producers typically handle scrap, and maybe you can just share a bit of your experience with us. Maybe Heiner, we would like to start.
Mm-hmm. Thank you. Scrap is always fashionable, but there's a lot of room for improvement, and that's what we are talking today about. And scrap is traded based on specifications like from ISRI, BIR. And these specifications give general guidelines on ferrous content, on copper content, but they're very general and they leave a lot of room for interpretations, for discussions between steelmaker and scrap supplier. I've here for you two photos. One shows typical HMS scrap, and you see a high content of impurities. Maybe this is a bit worst case, but still reality. A lot of steel producers are receiving scrap like this, and at this point we would like to improve the scrap so that steelmakers have less problems. And the other slide shows typical shredded scrap, and there we see copper impurities, and these copper impurities make in a lot of cases the use of this scrap, especially for flat steel producers, to a problem because of the inconsistency of this copper content. Mm-hmm. And there we want to supply and show solutions.
Mm-hmm. Very interesting. Thanks, Heiner, for bringing these pictures with us. I think this perfectly illustrates the state of the art or reality. So, Andreas, what do your experience regarding the automation of production and logistics? What is the standard way how steel producers usually do this nowadays?
Yeah, usually depending on the steel analysis you want to produce, a recipe for the scrap is sent to the scrapyard, and then according to this recipe a scrap mix is prepared, which is then sent to your melting unit. But of course, as Heiner already explained, you have to trust that actually the scrap you are loading is according to the specification, which many times it is not.
Mm-hmm. I see, okay. Yeah.
And scrap consumers are basing their scrap mix on a worst case in order to prevent any production risk.
Yep. Okay. So this then means that this actually way to handle scrap is, let's say, suboptimum, then, to put it that way, or?
At least we would say there's a lot of room for optimization. Yes.
Okay.
Mm-hmm.
And so we have seen now that obviously like unsorted and contaminated scrap is maybe very often the case with the standard and standard recipes, and that very often steel producers operate on the worst case scenarios. So what are then not drawbacks when you just follow this kind of policy or philosophy? Maybe you want to start again, Heiner.
Drawback is that the energy consumption is higher than it should be. Even the best furnace producer, Primetals, cannot produce steel from dirt. And so far, we would like to remove everything what is not contributing to a high liquid yield before the furnace. So steelmaking starts on the scrapyard. On the other hand, we also want to separate unwanted impurities like copper, lead, tin from the feedstock before it enters into the furnace. And that means that scrap needs to be processed so that it doesn't look like on the two pictures which we showed at the beginning.
Okay, very good. Anne, what about you?
The problem is, as Heiner said, that actually the impurities are undesired to have in the scrap mix. And nowadays there are possibilities, but there is quite low effort to track the quality of the scrap that is really charged into the melting units. And this is why usually steelmakers depend then on the experience of their operating staff, which of course you bring in the human factor. They don't act in the same way each day. Sometimes because of manifold reasons, the result of this is different, and therefore you are getting different results after tapping off your melting unit.
Okay, I see.
We want to make the use of scrap independent from human error.
Yeah.
That's the goal.
Yeah. And this is kind of necessary really to have this steady, very high quality ensured, and otherwise you have like too high fluctuations also on the end product?
Depends on the quality of steel which is produced. Especially integrated plants, flat steel producers have a strong move in the direction of the use of more scrap, and they are very sensitive to impurities, especially copper, tin. And this is something where we have to act and to show solutions to make the increased use of scrap for flat steel production happen. For long steel production, it's not so sensitive, but nevertheless, they have the problem of energy efficiency, and energy costs are rising all over the world significantly, so that we can optimize this as well.
Yeah. So in other words, we have to produce or to make the ingredients better to a grade that is required by the steel grade you want to produce at the end. So if you compare the steel making routes, like today, high quality flat steels, which are made in converter plants, there's only a scrap mix used to an extent of approximately 25, maximum 30%. And you can dilute this by using the rest of 80% of virgin material. So it is not essential, let's say so essential like in an electric arc furnace, where you go up to maybe 100% of scrap charge, and where impurities are then included in a much higher volume than compared to a converter.
Yeah, very good.
And we are in a transition period of the steel industry, heading towards CO2 neutrality, and the use of scrap, for sure we will discuss this later, the use of scrap is the fastest way to achieve this.
Very interesting point. So this is I think a good point maybe to just welcome also our possibly recently connected participants. Welcome to today's Pioneers Talk with the title How Crafted Scrap Can Improve Steel Quality and Reduce CO2 Emissions. We have just started to discuss, let's say, the challenges around this topic today. With me is Andreas Melcher from Primetals Technologies, as well as Heiner Guschall from SICON in Germany. If you have any questions at any time, please just input them as comments to this live stream. I've seen there are some comments already in the queue, so please add them. Later on, I will read some of your comments out as questions to our experts, and you will get an immediate answer. If we will not succeed to answer all the questions during this live stream, I will make sure that I will connect you later on after the live stream with our experts, so that hopefully we'll get an answer in any case. So please keep on inputting your questions as comments. So we have started to discuss now the challenges when handling scrap which is maybe polluted, and when automation is missing, and maybe the production is too much depending on the human factor, or actually varying too much. So where is now specifically space for improvement to your experience? Maybe you want to start with this.
Yeah, okay. So from automation point of view, of course, there are comprehensive solutions to make your logistic chain automatic, automation supported. That starts from the delivery of the scrap, followed by unloading, preparation or pre-preparation of the scrap, preparation of the scrap mix, and the transport of the scrap then to the melting unit, and tracking each single batch of scrap that is going to be charged into your melting unit. Plus there are intelligent sensors and technological packages that can support to identify actually the type of scrap that is charged or delivered. It even gives the opportunity to remove unwanted and dangerous ingredients from the scrap mix. And at the end, you can close the complete logistic circle and know up to 100% what you are feeding your melting unit. So if you know your ingredients, you can be quite sure about the result you get out of the furnace.
Mm-hmm. And so this means their automation gives a significant advantage compared to all like experience stored in human brains?
Definitely, it's not only a question of the experience, because as mentioned before, you never can be 100% sure what kind of impurities you have in the scrap if you do not check for roughly to find them.
Yeah.
So you have to trust actually that the scrap mix is according to the recipe, but you cannot be 100% sure if you do not put additional effort into the game to find out what kind of scrap you're really using.
Mm-hmm. Very good. So Heiner, where do you see specific room for improvement to your experience?
Basically, what Andreas said, that's the point where we are coming in. Scrap is today not a certified or quality-proven product. It can change depending on the market situation. There can be higher impurities or less impurities. That's difficult for steel plants to anticipate this, but they have problems with this. And so far, we want to make the utilization of scrap transparent. And transparent means that we have one step of pre-processing, preferably within a steel plant. And this pre-processing means that we take out all unwanted impurities which are already liberated. And the next step is then to know exactly the chemical composition. So first step, we have prepared a short video which shows our HMS-cleaning to convert this ugly HMS scrap, which we saw on the picture at the beginning, into a quality scrap. And here you see a unit. The scrap is fed to a pen feeder for a proper dosing, to a so-called HMS screen, inclined and acceleration of material, and then a magnetic separation, so that liberated non-ferrous metals, stones, fines, oxides are dropping down. Everything what is still ferrous is separated from the residue, so that nothing is lost. But by this we can increase the liquid yield by 6 to 10%, which is a significant amount. And furthermore, we can add steps together with Primetals so that the sheared scrap is further optical controlled, and that further unwanted impurities are separated, so that we get a quality product from the low quality HMS which we saw before.
Very good. Very impressive to see like this big like mountain of dirt which just came out.
Yes, that's indeed impressive. And when you consider that this material went before to the furnace and increased just the amount of slag and cost energy.
Yeah. Is this, let's say, it's been like standard, or was it like kind of worst case scenario as showed now in this video?
It's a bit strange. Steel producers who have such units in operation are wondering why they didn't do it before.
Okay.
Those who don't have it often say, we don't have such a scrap.
Yeah.
But when you look on the scrapyard, you don't see a big difference. So that's what I said at the beginning, there is potential. Yeah. Just by pre-processing, by analyzing, the scrap quality becomes transparent, and then you really see what you got.
Very interesting. So where is now your space for improvement, like from your like automation view on this topic?
Yeah, okay, maybe one important aspect I want to add, increasing the slag for many steel producers is a challenge because the disposal of slag in many cases is not free of charge. So you have to pay for it. So if you take all the dirt out before and you can decrease the amount of slag, of course your production will become cheaper, and that's of course another benefit of cleaning the scrap before you charge it into a melting unit. And yeah, so what we are having on solutions, I prepared some slides to show it to you. The first slide that will be shown now is an optical solution for the identification and classification of scrap. So you can see here actually a scrap chute in top view on its way to a steelmaking plant. And our technological package is here used to verify that the charging recipe and loading instructions are obeyed by the staff, and to be sure that the correct kind of scrap in the correct order is transported to the melting unit. On the second slide, you can see actually a 3D scan of the same transport. So you can see actually the truck pulling the chute in blue color, and in the red color you can see the scrap that is distributed inside the chute. The reason why we are doing this is actually to calculate the volume of the scrap that is charged into the chute. And we are doing this first of all to verify the master data that is stored in the database for steel production, so that actually the specific volume and weight of the scrap is correct. And secondly, to be sure that we can avoid any kind of problems when charging the scrap into the converter in this case. Because if the volume is very high compared to the weight, let's put it like this, sometimes it's happening that the scrap is getting stuck during the charging process, and of course this costs time to rectify, gives you a lot of troubles on the steel plant floor for cleaning, and so on and so on. So the system in general supports you to avoid such situation and making steel production more profitable and safer.
Mm-hmm. Very interesting. Thanks for bringing like these examples with you. So we have already some questions. So I suppose that we just have a look at them. Just one question, maybe I'd answer this just directly, because one of you is just answering. Will be the recording will be made available later on? Yes, it will be. On the one hand, when you go to the Primetals Technologies corporate LinkedIn channel, this recording will be available there as a video post on the one hand, and on the other hand, we will also publish the recording then later on our Primetals Technologies online metals magazine. We will post that link also later on. So if you have troubles in following our stream, but of course we are glad if you just try it hopping onto the stream. Some regions obviously internet connection is not perfect, but if it's not possible, please then have a look on the recording later on. So let's have a look at some questions. So the first question is here, like Edgar is asking, how do you imagine the scrap market will supply all the demand, since the increase of scrap is key for a lot of decarbonizing projects? of all? Like, do you have any experience in how the scrap market is evolving? Is there already like any limitations or shortages? Do you have any experience, Heiner?
The scrap market will remain tight during the next years. It is not possible to produce all the steel, nearly 2 billion tons per year, made of scrap. This is simply not possible. We don't have enough scrap. Of course, there's an increase of scrap arising during the next years, but 30–40%, maybe up to 50% can be covered by scrap. And insofar, there will always be a lack of scrap, and for sure also a certain fight for scrap. And that also leads to the assumption that scrap producers, scrap traders, don't have the necessity to produce a perfect quality. And insofar, we see more the task in the future inside the steel plants to refine the scrap to the quality they need.
Okay, I see. Interesting. Thanks for the answer. Something to add from your side?
So most likely this is the best and viable solution. In simpler words, trying to make better scrap out of bad scrap by cleaning and preparing it. And as Heiner already mentioned, it is, I think, crystal clear that the demand for high quality scrap will be increasing. And an alternative is to use virgin materials instead of scrap then in an electric arc furnace, for instance, which is from energetically point of view not desirable, because you need more power to melt such virgin materials, and in fact it has to be feared that even the availability of such virgin materials like HBI, for instance, will not be sufficient for the demand on the market.
Scrap can be converted up to the quality that there can be an exchange of DRI and HBI, so that you can react to the market conditions, which are challenging at the moment, and who knows what will happen during the next months or years.
Can you imagine? So another question, actually, like Francisco is asking, what about the dust generated during the grinding or storage in the open yard and afterwards in the EAF? So even in the images we have just seen, it seems that like there's a lot of dust generated. What is the strategy to deal with the dust? Maybe you have an answer for this.
When we are looking for shredded scrap, then dust is not an issue, because plants are connected to state-of-the-art dedusting unit. But I think our visitor is looking for processing HMS, which can be a dusty thing. But we have in our units dust suppression equipment, so that there is no diffuse dust emission. And furthermore, the cleaning unit is in a way efficient that 99% of fine dirt dust is separated, so that the scrap after the cleaning does not cause any more environmental issues or concerns.
Very good. Thanks a lot. Another question, this is I think also for you, Heiner. How can we, Eman is asking this, how can we exactly know the chemical composition of a batch by sorting scrap?
We are using online analysis. Maybe you want to show the video at this point?
Yeah, if it makes sense.
We have prepared one video which shows the EcoScan online.
Maybe you just, it's running, please.
Yeah. And the EcoScan online, here it is shown for shredded scrap, but we use it as well for sheared scrap. At the moment it's in operation at 2 steel plants or steel recycling companies, one innovative company in Germany, which is cooperating with a flat steel producer. And each batch which is supplied to the steel plant has to pass, or everything is passing this analyzer, so that each railroad cargo or truck has a quality certificate so that the final user, which is the steel plant, knows exactly the chemical composition. Of course, we can do this also at the entrance, at the gate. After the inspection of the scrap, we can of course also measure the chemical analysis to assign maybe the scrap to different sorting or processing equipment. This is also possible. But by this analysis, we are very close to the metallurgical chemistry so that we can predict in advanced how this scrap can be used.
Very interesting. Yeah.
And together with the optical tools that we can provide, you're getting the perfect combination to track the quality of the scrap that you're using in your production.
Maybe one question what you now exactly said, Andreas. This is coming from, where is it? There's no name displayed, just LinkedIn user, but anyway, can you scrap screening tool or equipment, is it able to separate stainless steel from copper and so on possible, or is this some topic for future development?
No, this separation, this separation is state of the art.
Okay,
that's not a problem.
Okay, perfect. All right, so please just keep on typing in comments to this live stream, as a lot of others did it before. We just go on now with our questions, but later on we try to read out again some other comments and questions. And if we do not answer all of them, as mentioned before, I will try to reconnect you after this live stream with our two experts so that the questions will be answered anyway. So in the title of this Pioneers Talk, we just stated that crafted scrap especially is the key to succeed in a high steel quality and in the production. So maybe you can elaborate a bit on this. What exactly now is crafted scrap and how can you produce crafted or use or provide crafted scrap to your steel factory?
Okay, so let me explain. Actually, crafted scrap is a scrap preparation system which consists of elements of electrics and automation plus mechanical components, providing exactly the kind of scrap and the quality of scrap for your target analysis in the required amount in the right time. So this you will get increased safety in your production, then decrease the energy consumption and increase the yield of steel in your melting unit.
So in your description, were there also now like solutions like a SICON is providing included, or is there something to be added? What crafted scrap is like from your point of view, Heiner?
Basically, it's to come to a digitalized scrapyard. It's a modular system. It's starting at the entrance. It's starting with the optical inspection, with the correct assigning to different scrap preprocessing facilities inside a steel plant, and then the analysis. So each step basically can be added in different phases, so nothing has to be done in one step. But basically with crafted scrap, we want to express that steel producers should not accept anymore the quality they get on the market, but that they get the quality, or that they refine the scrap to a quality which meets exactly the needs of the furnace and not the other way around.
Yeah. And we can provide all the tools which are necessary to come from one step. That means the scrap that you get and that you have stored on your scrapyard, to convert it into the scrap that you really need to produce the steel you want in your melting unit. So, and in between is this combination of electric and automation tools and mechanical tools, which can be provided by SICON and Primetals.
Yeah, and actually, so that this demand for crafted scrap, or the need, has this always been there, and the solutions were not in place, or is this something like both of you engineered the solutions and now can offer this kind of enhanced solution, or was it something like a demand which came up recently, and if this was the case, why?
So I believe due to this very strong trend, mega trend for reducing the CO2 footprint of steel production, it is became quite a necessity, because those high quality steels that are produced in electric arc furnaces, which are now produced in converters, need a special quality of scrap and scrap mixture, and this is where we actually target with our crafted scrap initiative and with our tools.
Okay, very good.
And modern electric arc furnaces, as Primetals designs and supplies them, are completely flexible from 0 to 100% scrap. Everything is possible. Whereas today the integrated plants, Andreas, you mentioned it, use 20 to 30% scrap. And that's the limit. More is not possible. And with the new technology, DRI, HBI plus electric arc furnaces, we are exceeding this limit of 30% up to 100, and therefore there's more demand for quality scrap, and therefore we see a significant increase of interest and demand in crafted scrap.
Yeah. And of course, in the view of CO2 footprint reduction, it is essential because increasing the scrap rate, so recycling material inside, and using environmental friendly produced energy to recycle this, of course, significantly reduces the CO2 footprint of steel production, which is very important nowadays.
In a very fast way.
Yeah.
Yeah, very good. Yeah. When we just talk about demand, maybe we can just share the results of a very small poll, an online survey I did prior to this event. There were just a couple of replies, but I think it's still very interesting when we talk about demand. On the one hand, I was asking you, are you already using solutions for processing, analysis and sorting of scrap at your steel plant? And there were like 3 options. As you can see, like, yes, I do. No, it isn't interesting for me at all. Or the middle answer, which all of you chose who actually answered to this poll, saying not yet, but I want to in future. So obviously what we're discussing now is interesting for a lot of you who attend this call now. And then we can have a look at the second diagram, at the second poll. This is exactly what we were just talking about. I was asking, do you think that the smart scrapyard can improve your steel production? And we had 3 options. The first answer, maybe it was a bit like exaggerated, but saying, okay, humans always outperform automation. Always none of the answerers took this. 2/3 choose the answer that automation improves steel quality, which is also the topic of our today's talk, where crafted scrap obviously is the key. And 1/3 of you just chose the option automation is essential. So obviously there is really a demand also regarding our participant audience here, and I'm glad that this is the case. And maybe before I proceed, we will have another look at our questions, because there are some of the questions coming in here. Let me see. There is a question from Vival, I think. So he's asking, a lot of impurities are found in the scrap. Refining and creating the perfect quality steel won't be costlier than normal steel production? Is this a question? So as removing all the impurities, so will this require a lot of processing? So I don't know, can I maybe give an answer to this?
That's a good question, which I cannot answer in a completely general way.
Yeah.
But what we see is that mechanical processing of scrap is very economic, and that the residue which are separated have usually a similar high value than the scrap because of the content of non-ferrous metals. And so far you are not definitely you are not increasing your average cost for scrap. You are reducing the average cost by scrap processing. Mm-hmm. And this becomes obvious when you have such a plant and look at the residue. It's very astonishing when you see the amount of non-ferrous metals which is supplied today to steel plants and used in furnaces and basically lost. This is not the idea of circular economy.
Mm-hmm. Very good point. Yeah. Thanks, Heiner. There's another question from Wolfgang. He's asking, where do you see the location for your scrap preparation process or processes? Should this be next to the scrap supplier or collector, or should this be backward integration for steel producers? So I know. So a question for you, maybe.
I can try to answer it. I think in general the best location is inside a steel plant. Steel plants have usually a number of different suppliers, and these suppliers have different ideas and understandings of quality. And in order to get these different suppliers on the same quality level, we need the step of refining inside the steel plant. Inside the steel plant, we usually have the space, we have lower energy cost, and the steel plant knows exactly which quality they want to have.
Mm-hmm. And is maybe a question for me, which just I have the impression that the solutions you provide might not need a huge investment like with a new technology, but might be a big potential to leverage if you use it as a steel producer. Is this the case?
If you compare the investment, we're not talking about specific figures.
Yeah.
If you compare the investments to DRI plants, to electric arc furnaces, rolling plants, we're talking about small figures.
Yeah.
As mentioned before, it can be installed step by step. Each solution is customized. Therefore, we have our scrappy here,
yeah.
Which should feature the customization
maybe we show him in the camera.
products.
Yeah? Maybe we can take him. He was scrappy actually. Thanks for being scrappy with you. Very nice. Yeah. So he can perfectly adapt his color. Yeah.
Yes.
Yeah. To the
and it adapts to the environment and to the necessities of a steel plant.
Very nice message.
Yeah. The same, of course, applies to the automation packages.
Mm-hmm.
So they are totally modular and can be integrated into an existing automation environment in a steel plant. And depending on the necessities and the needs in the steel production, they can be added step by step and add up then to a complete solution in the best way, together with mechanical preparation and sensors coming from SICON.
Yeah, very good. There's an interesting question. This is for you, Andreas. Saya is asking, is it possible to replace like a blast furnace by 100% grafted scrap in a large EAF in terms of economic production? Do you think this is an option nowadays, to replace a blast furnace via EAF using like grafted scrap then?
Yes, of course, this is possible, and many steel producers which are using now blast furnace and converter routes are planning exactly to do that. But as said before, our electric arc furnaces are very flexible, so they even could use the pig iron that is coming from a blast furnace to be charged into the electric arc furnace together with a scrap and other virgin materials. So it depends, I would say, on an individual solution that, of course, has to be checked and found the best way how the steel should be produced.
Very good. Thanks for answering this. Yeah, please just keep on typing in your comments to this live stream. We won't succeed to answer all of them, but as I promised you, I will follow up them properly so that they will get an answer from my experts after this stream as well.
Seem to be a lot.
Oh, there's a lot of coming in. Yeah, thanks a lot for interest. Obviously, really hit the nerve in the market, showing also like our very small polls at the very beginning. So maybe 1-2 questions at the very end. What I'm interested in, I read in the newspaper some time ago that Primetals Technologies and SICON recently signed an agreement for a cooperation. So maybe you can just explain us what was the motivation for this agreement and what are the benefits for the steel producer due to this agreement. What has changed compared to the situation before signing this agreement?
So I believe actually that our sensors and together with the EcoScan of SICON that you could consider as the brain of the scrapyard, together with the mechanical solutions, scrap preparation, cutting, shredding, cleaning, sorting, baling, and so on, which are practically speaking the limbs, are fitting perfectly together to provide our customers with solutions which perfectly integrate them in their steel production and provide them with the scrap and the required quality to produce their steel.
Very good, yeah.
Yes, our solutions are complementary, and when we want to achieve a scrapyard 4.0, a smart scrapyard, then all these solutions are necessary, and each solution gives a benefit.
Very good, yeah. So another question which is also interesting for me, the solutions you presented so far, we were discussing about, as far as I can see, let's say they are really rather smart, making a scrapyard very smart. At the end, pimping it up. Are these now solutions which really contribute to moving me as a steel producer further on my road towards Industry 4.0? Or let's say, is it just like a kind of advanced automation system which is living in a pulp pit?
No. Actually, it definitely moves you into the right direction towards Industry 4.0. All of those solutions can be integrated in Primetals Industry 4.0 environment, collecting all the data that actually then can be used to enhance your steel production. So it is fully compatible and integratable.
Yeah, very good. No, very impressive. And to your experience, Andreas, when is then a scrapyard really smart? Is there a certain state where say now it's smart, or how do you define this?
Yeah, as an automation guy, I have to say my wishful thinking is the scrapyard really is smart when all the tribal knowledge and the experience of human operators is integrated into the automation system and can be used then to the maximum degree of repeatability during the process. That's my automation point of view.
Very good. Yeah. There are a lot of people now online, as far as I can see. Thanks also a lot for your interest to the participants. I think there are a lot of steel producers, of course, are on because this is especially designed for them. So if someone is really interested to say, okay, this is interesting for me, I want to pimp up my scrapyard, I want to convert my scrap into crafted scrap, I want to utilize or leverage the potential for my steel production. So to whom shall he write, whom shall he contact?
Yeah, okay. I gladly will collect all those inquiries, questions, whatever our clients need. And of course, we are in constant contact with SICON, and we exchange all the information regularly so that we can then serve our clients with the right answers and products, hopefully.
Okay, perfect.
We will do our best.
Yeah. So this means whenever you have any specific question, please just either contact Andreas Melcher directly, as well as of course Heiner Guschall for these solutions. I will put later on again a link to their personal LinkedIn profiles, but of course since you have registered for this Pioneers Talk today, their LinkedIn profiles anyway connected at this event page as well. So I think we've come to an end basically of this today's live streamed interview. I hope you loved today's topic. I hope the answers of our two experts inspired you and were interesting for you. I hope you love this format Pioneers Talk, which we are actually broadcasting on a regular basis. The next Pioneers Talk, by the way, will be related to level tracking. We're going to discuss actually what is level tracking, and that it's much more than just determining where is the position of the ladle. This is actually anyway a topic I think of this which is very well connected to what we discussed now. It's also logistics, but of course just in the melt shop, not regarding to scrap. If you're interested in this, please just either follow the hashtag Pioneers Talk or just keep an eye on the corporate channel of Primetals Technologies or follow my LinkedIn profile, so you for sure will get then a notification about our next talk. Please keep on commenting if you like in this stream. As I promised, I will follow up your comments properly. Thanks for being with us. Thanks for your interest. I was overwhelmed by all the comments and the reactions. Thanks a lot for that. Thanks also to our experts, Andreas, for being here.
Yeah, thank you too, and thanks to our audience.
And also thanks, Heiner, for being with us and for your interesting answers.
Thanks a lot. It was a pleasure.
Perfect. Thanks again and goodbye.